Hello students, in this video we are going to learn about the data types in Python, type conversion, that is converting one data type to another, that is implicit and explicit type conversion, then framing expressions in Python, like how to frame a proper expression, what are the valid expressions in Python, then how to assign values to variables and all that. Now let us get into the session. So there are different types of data types in Python. The first are numbers. Next, sets. There is a special data type called none. There are some sequence data types. Then we have mappings, that is dictionary data type. So first, let's see what are the numbers that are supported. In the previous session, I already told you there are numbers like int, float, and complex. Int, integers. Float are floating point numbers. Integers are numbers without decimal places, whole numbers. For example, 52, 75, 9562, something like this, which do not have any decimal place. These are integers. When you talk about floating point numbers, we have numbers like this: 0.52, 75.52, 0.9562, 0.00067. All these data types are float data types. Complex numbers have a real part and imaginary part. For example, you have 5 plus 4j. This is a complex number. This is the real part and this is the imaginary part. When you talk about sets, these are the ones that we learn in set theory in mathematics. Ones that are enclosed within brackets like this. Say you have some numbers like this. These are called sets. This is a data type in Python. Then you have special data type called none, where you don't assign any value. When you say x is equal to none, which means nothing. As of now, I'm not assigning any value to the variable x. But maybe in future, I'm going to assign some value. I'm just introducing the variable to the program. So you can use none as a data type. Nothing. When you talk about sequences, we have three important data types: strings, lists, and tuples. What are strings, lists, and tuples? Strings, lists, and tuples are indexed and ordered data types. What do you mean by indexed and ordered? First, let me tell you what a string is. If you remember in the last class, I told you whatever you enclosed within a single quote or double quote or triple quote is called as a string. Inside a string, first you have to understand how a sequence data type is stored in memory, how a string is stored in memory. If you have a string called ABC, how is this stored in memory? This is stored in this way: A, B, C. And say the address of the memory location is 53046 or something like that, and these are stored in a sequence, and every element has an index. What do you mean by index? It is like a reference: 0, 1, 2. An index always starts with 0. The first element of a string has an index 0, the second element has index 1, the next element 2, and so on. So the last element index will be the length of the string minus 1. Suppose the length of a string is 10 characters, the last index would be 9. Starting index will be 0. 0 will be the starting index, last index will be 9. That is the length minus 1. So this is why we call it as indexed data type. What do you mean? What is the purpose of this index? Suppose you want to take a particular or refer to a particular element in ABC. You want to refer to the third element in a string. Then how do you refer to it? Suppose you have S is equal to A, B, C, D. When you say S of 2, You have to refer the index within square brackets. S of 2. What do you mean by S of 2? I'm referring the index number 2 inside the variable yes. What is index number 2? This is 0, this is 1, this is 2, and this is 3. So I'm actually referring the alphabet C. Suppose you have A, B, space, C, D inside yes. This has index 0, 1. Space is also counted as a character, so it has index 2. This is index 3 and this is index 4. So yes of 2 will now be referring the space which is stored in index 2. So using index, we will do a lot of programs that you will learn in due course of time. Now just understand what is the purpose of index. When we talk about index, let me tell you some other thing also. You have a reverse index which is also used to refer to the string elements. The reverse index starts from this way. It goes this way: minus 1, minus 2, minus 3. The last element has index number minus 1 and the previous element has minus 2 and the minus 3 and so on. So using the reverse index or this index, you can use any method to refer to an element. So when you have ABC in a string, s of 0 is also A, s of minus 3 is also A. So you can use different methodologies. Either you use this index number or you use this index number, both mean the same. Now, what is a list? A list is also a sequence data type, and a list is referred to continuous information that is enclosed within a square bracket, and every element is separated by a comma. For example, you have 10, 20, A, B, then XY. So this is a list. When you say L equal to, enclose all the elements inside a square bracket, each element separated by a comma, it becomes a list. Again, this is also an ordered indexed data type. What do you mean by that? The first element has index 0, second element has index 1, third element index 2, fourth index 3, and so on. Same way, the reverse index is also applicable in list, which is minus 1, minus 2, minus 3, minus 4. It goes this way. The index number is the same in the case of strings, lists, tuples. The same methodology is followed. Now, what about tuples? When you say tuple, a tuple is enclosed with this kind of a bracket, the rounded bracket. The same variable, say 10, 20, 30, x, y, z, or any kind of Python data type can be given inside a tuple or a list, both. Again, the index number goes this way, and the reverse index is this way. This is a data type called tuple. Now, when you look at a list and a tuple, you may think that both mean the same. Then, what is the purpose of having two different data types called list and tuples? Now comes the concept of mutability. There is a concept of mutability in Python. Before you learn the meaning of mutability, you must understand how variables are stored inside the memory in Python. Now, whenever you create a variable, say I assign x equal to 10, then I assign y equal to 20. What happens actually inside the memory locations? There is an element which has a value 10. There is another location which has a value 20. Now, Python does not create a container called x and then put the value 10 inside. There is a traditional method of storing values in a data types, like you have programming languages like C, C++, and all. How is a variable created? When you create a variable, a memory location will be created for x and another location for y. And when you assign x is equal to 15, the value 15 will be stored inside x, inside the container x, and y will have 5 inside. Now, at any point when you say x is equal to 20, this 15 will be replaced with the value 20 because x is the container, it stays in the same place, only the value keeps changing. This is how allocation of value inside a variable takes place in the traditional programming languages like C and C++ or many other languages. But in Python, the value does not change. The value 10, 20, and all remains in the same place. Only a tag with the name of the identifier is placed for the memory location. So when you assign x is equal to 10, the place or the memory location where the value 10 is stored, x will be tagged to that location. Y will be tagged to location which contains the value 20. Now, at any point, when you assign x equal to 15, what happens? This value is not erased and 15 is not replaced. Actually, there will be a place where 15 is stored, and this tag will be removed from this place and will be pointing to 15 from now on. This is how the assigning of values happen in Python. Same way, when you say y is equal to 10, now this pointer, this tag moves to this place. Why? A value called 10 will never be replaced with a value 15. The value 15 will be never replaced by another value. What are 10, 15, 20 and all? They are all integers. Because they are not replaced by another value, they are called immutable data types. What is immutable? You can never replace one value with another value. They are called immutable data types. So Python will not replace any number with another number. They are all stored in different locations. Only the name of the identifier works like a tag and is taken from one place to another place and hanged in some other place. When you assign a new value, the tag only changes, but the value will never change. Okay, so this kind of a data type is called immutable data type. Now, what are immutable data types? Int, float, complex numbers, and tuples are immutable data types. Strings are immutable data types. You can never change the value given inside a string. But lists are mutable data type. List is a mutable data type. Now, how does it work? This mutability and immutability in a list and a tuple. Say you have a list called 10, 20, 30. Lists are mutable data types, which means one value can be replaced with another value. So at any point, when I say L of 1 is equal to 25, so you know the index number 0, 1, 2. What is L of 1? 20. Now when I say L of 1 is equal to 25, this 20 will be replaced with 25, which means inside the memory location, there are three values called 10, 20, 30, where Python will remove this 20 and replace it with 25. Why does it do this? Because list is a mutable data type. But in the case of a tuple, when there is a value called 10, 20, 30, when you say t of 1 is equal to 25, when you try to do the same thing with a tuple, this will never happen. This will cause an error because a tuple is an immutable data type. You cannot replace one value with another value inside a tuple because it is an immutable data type, right? Anyway, we will discuss in detail about all this when we learn in the further chapters. When we learn about strings, list and tuples, we will learn about the working of all this. Next comes the mapping data type, where you have a data type called dictionary. There is a data type called dictionary. Now, dictionary is another data type which stores values in a sequence, but it does not store it in any particular order, which doesn't have any index like the 0, 1, 2 and all. Now, let us see how a dictionary is created. You create a dictionary with a key value pair. What do you mean by key value pair? When you create a list, say you have a list called D, 10, 20, 30. Now every element has an index number. You can, so suppose when you say D of 2, it means you are referring the value 30. When you say D of 0, it means you're referring to the value 10. That is, each element is accessed with the help of the index number. But in the case of a dictionary, it doesn't have any index. It is an unindexed data type. So, what will happen? You have the freedom to assign a key for every value. You yourself can have something like an index. You don't refer it to as an index actually, it is a key which refers to a value. The same thing you can write this way: 1 colon 10, 5 colon 20, 6 colon 39. This is a dictionary. In this dictionary, the first part, this is the first element, this is the second element, this is the third element. Every element is a key value pair. The actual value is 10, 20, and 39. But to refer to these values, we do not have an index. So I myself assign a key for every value. So what is the key of 39? It is 6. So when I want to refer 39, I should say D of 6. When I try to print D of 5, I am actually referring to the value 20. When I try to print D of 1, I am actually referring to value 10. Because these are all re- the keys are used to refer to the values, they should be unique. You cannot have a duplicate key. But the values can be duplicates, it will not cause any trouble. Okay, fine. So the different data types that are used in Python, there are numbers which have int, float, and complex type of numbers. All these three are immutable data types. Set is another data type which works exactly like a mathematical set. It does not have any duplicate values. That is one thing which you should understand. There is a special data type called none. When you don't want to assign any value to a variable, just simply create it. You can assign a value none. Then a sequence data type, there are three data types called strings, lists, and tuples. Out of this, strings and tuples are immutable data types and lists are mutable data types. And they all have an index to refer to the elements inside them. Then coming on to mapping, we have a dictionary data type. Inside a dictionary, you don't have an index to refer to the independent elements. For that purpose, you have keys to refer to the value, right? Okay. Now, let us learn how to create a variable, how to assign multiple values to multiple variables, and all that. Okay. When you want to create a variable, you have to use an identifier name, for example, x. What value do you wish to assign to the variable? Say 100, and you have to use the variable name in the left hand side and the value in the right hand side. So, what are the different ways of assigning values to a variable? The left hand side should always contain a single identifier. You can never say x comma y comma z is equal to 100. This is wrong. Python does not allow more than one variable in the left hand side. The left hand side, always remember the rule is the left hand side should contain one identifier only. A single identifier should be there in the left hand side. Don't give any operator or any expression in the left hand side, which means your statement is wrong. When you say x plus y in the left hand side, it is wrong. The left hand side should always contain a single identifier. And what is allowed in the right hand side? The right hand side can contain a literal. What is a literal? It is a constant like 100, 1000, 5.5, 22.65, some value. Any data type which is allowed in Python, any variable, you can have literals, you can have variables or identifiers, you can have expressions in the right hand side, you can have uh, values like this. See, combination of expressions, say y is equal to x plus 10. So you have a variable here and a literal here. This will be evaluated by Python and the result will be saved in y. Again, it is a single identifier on the left hand side. So this expression is correct. You can assign a single value which is allowed. You can assign an expression which is also allowed. You can have a variable, which is also allowed. Whatever is the value of x will be assigned to y. But only thing is, you must have assigned a value to x previous to this expression. Otherwise, you will get an error saying that x is not defined. So, in the previous expression, some point you should have some variable for x. Only then that value will be assigned to y. So you can have a variable, you can have a literal, you can have a combination of expression which will be calculated and the result will be stored in the left hand side. This is how a variable is assigned, and when you assign it, directly Python will understand what kind of a variable is x. In the traditional data types, in the traditional method, the data type has to be introduced first to the program. In the traditional method, like programs like C, C++, you have to introduce the variable saying that A is an integer, B is a floating variable, kind of things are needed in other programming languages. But in Python, you just have to say A is equal to 10 in an expression, B is equal to 5.5. Now you can, there is a method called type. Type, put an open and close bracket, which means it's a method. Type of the variable name A. When you type this in Python, you will get an answer saying class int. What does it mean? Python has understood that 10 is an integer. Same way, when you check what is the data type of B, you will get class float, which means because it contains a decimal place and a number after that, it automatically understands that it belongs to float data type. So you need not introduce the variable's data type. Python will automatically understand the kind of data type. When you say C equal to 5 plus 4j, it will understand that it belongs to complex data type. When you say X is equal to true, what is true? I hope you remember, true and false are Boolean values. So X becomes a value of Boolean data type. So when you check type of X, it will print it as bool. Bool stands for Boolean data type. Right? Now, whenever you create a variable using an expression like this, after creating the variable, you can use the type method to find out or check what kind of a data type is this variable. Same way, when a variable is created, it stores, it tags the value 10 in the memory location. In any case, you wish to know where this value 10 is stored inside the memory. If you remember, every memory location inside your computer has an address. There is a unique memory address for every memory location inside your computer. Say 5,45,092, something like this, some number like this. Suppose you have values, the 10 which belongs to variable A is stored in this memory location. There is a method called ID. What is the use of this ID? ID of A will give you the unique memory location address where this A is stored inside the computer's memory. Same way, when you say ID of B, if you assign a value called b is equal to 5, and this b is stored somewhere here whose id is like this, then when you type id of b, this number, that is the address of the memory location where b is stored, will be printed. So remember, there are two methods called type and ID, which can be used to find out the data type of a variable and the address of the memory location where the variable is stored. So these two things will help us in a lot of programs. So when we start doing programs, we will know how to implement the usage of it, right? Next, now we have learnt about data types. Now we know how to find out what data type every variable belongs to using the type method. You have to learn the meaning of type conversion. What do you mean by type conversion? For example, you have a variable called 10. For any reason, You want this to be converted to float data type. Then, how do you do that? You have a method called float. Float of the variable name. What variable? The variable which you want to be converted into float. So when you say float of A, B is equal to float of A. Now what will happen? The value of A, which is 10, is converted into float data type and is stored inside B. Now what will B contain? 10.0. It adds a decimal point and converts it into a floating data type and saves inside B. But remember, A is unchanged. A is never changed. It is changed and saved inside B. So I hope you remember this. A is equal to 5, B is equal to A plus 5. Now what happens here? A remains as 5. Substitute this value 5 plus 5, B gets 10. When you say A plus 5, the value of A does not change. The value of A is used in another expression, right? Same way, the data type of A, the original data type does not change. A remains as an integer, B becomes a float. Suppose you want A itself to become an integer, you can do this. A is equal to float of A. So what happens? A is converted into a floating point variable and replaced inside A itself, substituted inside A itself. So integer A disappears and from now onwards, A belongs to floating data type. Right? This is called type conversion. What kind of type conversion is this? When you say, for example, you have 5.5. A is 5.5. What is 5.5? It belongs to float data type. When you say A equal to int of A, what happens? This is converted to an integer. How is it converted to integer? Python simply truncates all the digits after the decimal point, whether it is zero point 0.9 or zero point 0.5, no rounding off. It simply cuts all the numbers after the decimal place and A now becomes 5. So this method of converting one data type to another using functions like int, float, complex, bool, and all these methods like this kind of conversion is called as explicit type conversion or otherwise called as typecasting. So, this is an important question. You will be asked, what is the meaning of typecasting? When you try to convert one data type to another data type using methods like int, float, complex, bool, and all this, then it is called as typecasting or explicit conversion. Now, if you observe the word explicit, then there should be another type conversion called implicit conversion. So we let us see what is implicit conversion. What is explicit? The user specifically does all these conversions. For some purpose, we are doing the conversion. But what is implicit conversion? When you have a variable called 5, A which has value 5 and B which has value 10.2. And when you try to add C is equal to A plus B, Python will not work with two different types of variables. Say you have 5 here and 10.2 here. It doesn't directly add an integer and float. Now, what will it do? It will convert the other variables, all the variables to the same data type and then do the expression, then evaluate the expression. What is the preference that is given? Out of two variables, if one is float, the other is also converted into float. But when there are two data types which have the same two variables with the same data type, no conversion takes place. When you say C is equal to AB, suppose A is 3 and B is 2. Both are integers, so no type conversion happens. But when one variable is an integer and another is float variable, then Python will convert the integer into float. How does it convert? It will automatically make that 5 as 5.0 and the answer will be 15.2, which will again be a floating data type. This conversion of A into 5.0 is called implicit type conversion. When I say the value 5 is converted into 5.0, the original value of a will not change. The substituted value in the expression will only change. But a will always be 5 unless you mention a is equal to 5.0. The original value will never change, it remains as 5. So Python will automatically convert the data type before evaluating an expression. When there are a mix of two different data types, it will convert into the same data type. That is called implicit conversion, which is done by Python itself. Explicit conversion is done by the programmer for while working with any program. Right? Hope you understood what is type conversion. Now, that's all in today's session. In the next session, we learn about operators and operators associativity. Thank you.